Hey there. So if you're watching this, chances are your Whirlpool, Maytag, Amana, or KitchenAid washer has just decided to quit on you, flashing that really annoying F2 or E2 error code. Well, don't worry, we're going to figure this out together. Let's dive in and decode exactly what your machine is trying to tell you. Yup, there it is, that blinking code on the display, a tub full of soggy clothes, and a machine that's just stopped. It's a super common problem, believe it or not, and we're about to walk through a really clear, step-by-step process to figure out exactly what's gone wrong. So what does F2 or E2 actually mean? Well, the best way to think about it is like a failed handshake. Your washer's main brain, that's the main control board, tries to talk to the motor control board, but for some reason, it's not getting a signal back. That handshake never happens. It's a communication breakdown, plain and simple. Okay, so now that we know what the problem is, a communication failure, it's time to figure out why. We're going to treat this whole thing like a detective case, and our very first step is to line up the usual suspects behind this breakdown. And the number one offender, the part that's responsible for this error more than any other, it's the motor control board, sometimes called the ECU. You know, if your machine was working fine 1 minute and just stopped the next, this guy is immediately our prime suspect. Now, even though that motor control board is the most likely culprit, it's not the only possibility. So here's our full lineup, pretty much in order of how likely they are to be the problem. You've got the main control board, the motor itself, the wiring that connects everything, and a little piece called the rotor position sensor. One of these is almost certainly our bad guy.
All right, it's time to roll up our sleeves and get our hands dirty. This part is your step-by-step guide to actually testing our suspects and zeroing in on the real cause. So, if you've got some tools handy, let's start the actual detective work.
Okay, before you do anything else, and I absolutely cannot stress this enough, this is the most important step. You have got to unplug the washer from the wall. Seriously, we're dealing with electricity here, so for your own safety, please make sure that machine is completely cut off from power before you even think about the next step. Our first move? It's the easiest one. Just leave the machine unplugged for a solid 2 minutes. You'd be surprised, but sometimes this is all it takes to reset the electronics and clear a temporary glitch. While it's unplugged, just take a quick peek around the back for any obvious damage. Then plug it back in and cross your fingers. So if the reset didn't work, our next job is to check the lines of communication themselves. We need to take a look at the wiring harness. That's the bundle of wires running from the motor at the bottom of the washer all the way up to the main control board. This is the physical pathway where that handshake is supposed to happen.
So what are we actually looking for? You want to get a good look at the plastic connectors on the ends of those wires. You're hunting for any signs of trouble. You know, burn marks, any melted-looking plastic, or that greenish crud that means the pins are corroded. And pay really close attention to the 6-pin connector. A bad connection right there is a classic cause of this error.
Okay, so what if the wiring looks totally fine? Well, now we have to move on to some more advanced testing. The most reliable way to figure this out at home is what we call the swap test, basically testing and eliminating parts one by one. And to do that, you're going to need one essential tool, a multimeter. This is how we're going to gather our electrical evidence. Our first electrical test is going to be on the motor, specifically the stator windings. The stator is just the part of the motor that doesn't move. It's got all those copper wire coils. We're going to use our multimeter to see if those windings have the right electrical resistance, and just as importantly, to make sure they haven't shorted out. And the results of this test are actually really straightforward. First, set your multimeter to ohms. When you test between the winding terminals, a good motor should give you a reading somewhere between 1.0 and 5.0 ohms. Then test each of those terminals to the metal frame of the motor. You should see OL, which means open line. That's good. If you get any other reading, it means there's a short and that motor is toast. Next on the checklist is the rotor position sensor. It's a small part, usually has a 3-wire connector, and its whole job is to tell the main brain where the motor is in its spin. With your multimeter still on the ohm setting, you're just going to test between the different pins on its connector. If you get a reading of 0 or OL between any of them, that sensor has failed and it's time for a new one. So let's pause for a second. What if the motor tests out fine and the sensor tests out fine too? Let's look at the evidence. The wiring looks good, the motor is good, the sensor is good. Well, by process of elimination, our investigation points us right back to our number one suspect, the motor control board. That's the logic behind the swap test. Now, listen up, because this is a really, really critical point. If you figure out that the motor control board is the problem, you should absolutely replace the rotor position sensor at the same time, even if it tested okay. Why? Because a failing sensor can send a voltage spike that will instantly fry your brand new control board. And then you're right back at square one.
So, with your diagnosis complete, you're facing the final question. Do you try to repair this thing yourself? Do you call a professional? Or is it maybe time to just think about a new machine? Let's break down those options.
A do-it-yourself repair can save you a ton of money, especially if you're comfortable using a multimeter. The parts themselves might run you somewhere between $150 and $300. Now, calling a professional gets you an expert and a warranty, but it's obviously going to cost more. It really just comes down to your budget and how comfortable you feel tackling it. You know, a lot of times the biggest deciding factor is just the age of the washer. A good rule of thumb is this. If your machine is over 8 to 10 years old, the cost of a big repair can easily be half the price of a brand new, more efficient model. It's a really important thing to think about before you start buying parts. Okay, I know that was a lot of information, and it can definitely feel a little overwhelming. So let's just bring it all back and focus on the single most important thing you can do right now. Here is your mission. Go to your washer, unplug it, and just do that detailed visual check of the wiring harness we talked about. Look really closely at every single connector, especially that 6-pin plug on the motor. You'd be amazed how often the entire problem is just a simple burned wire that you can spot with your own eyes. No tools required. So there you have it. You've got the knowledge, you've got the procedure, you know the suspects, you know the test to run, and you know what the evidence looks like. The only real question left is, are you ready to get in there and solve this case?